Today, we are tackling a topic that, honestly, can sometimes feel like a heavy buzzword soup: data mining. But don't worry. My goal today is to help you completely master this for the exam without getting bogged down in complex coding or advanced math. You do not need to be a software engineer to ace this section. You just need to know how to think like a strategic financial leader.
Here's our roadmap for today's explainer. 1. Welcome to data mining. 2. Supervised versus unsupervised learning. 3. The big 4 techniques. 4. Data mining exam traps. And 5. We'll wrap up with a practice question walkthrough.
Okay, let's dive right into this with Section 1, Welcome to Data Mining.
So what exactly is data mining anyway? Put simply, it's using specialized tools to sift through millions of raw, completely messy database transactions to discover hidden patterns and pull out valuable nuggets of actionable insight. And let me reassure you right now, because I know this stresses people out, the CMA is testing your ability to identify patterns and match the right technique to the right business problem. They are absolutely not testing your ability to sit down and write algorithms from scratch. So you can take a deep breath, relax, and go ahead and put those Python textbooks away.
Think of data mining like literal gold mining. You're starting with these massive mountains of raw earth. It's disorganized, it's overwhelming, and frankly, it's full of useless dirt. But by using the right tools, you sift through all of that noise until you find that one gleaming nugget of gold. For us as financial professionals, that gold is the insight that helps us spot fraudulent transactions before they spiral out of control, or predict customer loan defaults, or severely refine our budget forecasts. It is a massive value add to literally any organization.
Moving right along to Section 2, Supervised versus Unsupervised Learning.
Now, pay attention here because the CMA absolutely loves to test whether you know the difference between the two main types of machine learning. We have supervised learning on one side and unsupervised learning on the other. Supervised learning is guided. You feed the algorithm historical data that already has labeled outcomes. It's exactly like studying for an exam with the answer key right there at the back of the book. For example, if you want to predict whether a new loan applicant will default, you feed the model 1,000 past applicants where you already know their payment outcomes, defaults and non-defaults. Unsupervised learning, on the other hand, is completely exploratory. You give the algorithm raw data without any pre-existing labels. Think of this like dumping a jar of mixed international coins on a table and sorting them purely by their shapes and sizes without actually knowing what currency they are. A great CMA example would be letting a system group your customer base into distinct demographic clusters just to see, naturally, who is buying similar products. There are no preset names, just organic discovery.
All right, let's look at Section 3, the big 4 techniques.
Matching each of these next 4 techniques to its specific business application is absolutely critical for snagging those easy exam points. To make this as straightforward as possible, I want to share my golden rules of thumb. Let's go ahead and call them Claire's exam tips. When you are looking at a multiple choice question, I want you to pay close attention to the requested output. If the desired output is a category, like approved or denied, you are looking at classification. If the output is a continuous number, say predicting $150,000 in revenue, that's regression. If you are trying to find new groups in your data without any predefined labels, you want clustering. And finally, if you're looking for items that frequently co-occur or are bought together, that is association rules. Keep these heuristics right in your back pocket for test day.
Now, what's really interesting about this slide is how this master matrix brings it all together. First up, classification. This is supervised. It categorizes data into predefined groups based on historical rules. A real-world CMA example, sorting incoming invoices into high risk or low risk for auditing based on past fraud cases. Second, regression. Also supervised. It predicts a continuous numeric value. Think about estimating next quarter's dollar amount overhead costs based on expected machine hours. Third, clustering. Now, this one is unsupervised. It groups similar data points without preset categories. For example, segmenting hundreds of retail store locations into performance clusters to organically identify which branches are underperforming. And fourth, association rules, also unsupervised. This is your classic market basket analysis. It finds relationships between items that happen to occur together. A great example is an insurance firm discovering that clients who buy term life insurance also tend to buy disability policies within 6 months. Which brings us to Section 4, Data Mining Exam Traps.
Look, it's not all sunshine and perfect predictions. The CMA exam doesn't just test what these algorithms can do, it actively tests your awareness of what goes wrong when accountants rely on them blindly. The exam setters use literal traps to trick unprepared candidates. You need to watch out for 3 major conceptual pitfalls: overfitting, data dredging, and data quality or bias. Let's break these down so you absolutely do not fall for them on test day.
First is overfitting, which I like to call the memorization trap. This happens when a model is tuned so perfectly to historical data that it practically memorizes it, including all the random noise and weird outliers, instead of actually learning the underlying pattern. So the crucial point is that a model might perform flawlessly on your past training data, but it will completely and utterly fail when you apply it to new, real-world financial data. It's kind of like memorizing the exact answers to a practice test instead of learning the actual concepts. When the real test throws a curveball, you fail.
Next up is data dredging, also known as p-hacking or data snooping. This is when an analyst continuously tests hundreds of random variable combinations until they finally find a statistically significant relationship purely by accident. You have to remember, correlation does not equal causation. My absolute favorite example of this is that, historically, ice cream sales and swimming pool drownings both rise at the exact same time. Did the ice cream cause the drownings? Well, of course not. The summer heat caused both. Don't let your algorithms trick you into making bad business decisions based on pure coincidence. And lastly, always remember the golden rule of data. Garbage in, garbage out. If your historical accounting records have missing entries or flawed data, your shiny new algorithm will literally just automate and amplify those mistakes.
Okay, Section 5. Practice question walkthrough. Let's see what you've learned.
All right, it's time to shift gears instantly into test-taking mode. Let's put this newly acquired knowledge to the test, right now. Here's a question framed straight from the ICMA blueprint. Read along with me here. A retail company analyzes millions of point-of-sale transactions and discovers that customers who purchase flashlights during autumn months are 65% more likely to also purchase batteries and emergency canned food during the same visit. Which data mining technique did the company use to uncover this pattern? Your options are A. Linear regression, B. Association rule mining, C. Supervised classification, or D. Hierarchical clustering. Think back to those heuristics we talked about earlier. What is the actual output here? We are looking for things that happen together, right?
Let's break it down and eliminate the wrong answers, just like we would if we were standing at a whiteboard. Option A is incorrect because linear regression predicts continuous numbers, not item co-occurrences. Option C is incorrect because supervised classification assigns items into predefined categories based on labeled training data, which definitely isn't happening here. Option D is incorrect because while clustering does form groups of similar data points, it doesn't give you those specific if X is bought, then Y is bought rules. And this brilliantly illustrates why option B is correct. Finding items or behaviors that occur together in transactions is market basket analysis, which is the classic definition of association rule mining.
You absolutely nailed it. See, data mining isn't so scary when you just break it down into business applications. Remember, making the distinction between supervised and unsupervised learning is your foundation. And always keep an eye out for those tricky traps on exam debt. You are building real strategic expertise right now. I am so proud of the work you're putting in. Keep working hard, stay confident, and I'll see you in our next explainer. But until then, I'll leave you with this thought. In a world completely drowning in raw data, the professionals who can sift through the noise to find the actual gold are the ones who are going to lead the future of finance. So are you ready to use these tools, make better decisions, and finally get those 3 letters, CMA, after your name?